Hello everyone. Okay, so this little video was about independence. It's in chapter 4, and the question came up because of this problem right here. If you look over here, do people of different age groups differ in their responses to email messages? And if you look down in part C, it says, are the two events answer quickly and the age of respondents independent? And I got stumped because I couldn't figure out exactly what they were talking about, the two events. Answer quickly was easy enough, but there were two different ages of respondents. There was a young group, relatively young, 12 to 50, and there was another group over here. And it kind of stymied me in class, and so I was afraid to take an answer. But now that I'm back in my office and I have a moment to look at this, I can see that it's really kind of straightforward. So how about let's go ahead and work this problem again. I put my face off of here so you can see better. So this is how it would likely look if I were to give you a problem like this on the test. I wouldn't give you the totals, I would just give you the observations and I would ask you to find them. And here's how you do that. So that's the total for ages 12 through 50, and then I can just copy that thing over there. That's the totals for ages over 70. And then for the responses that said yes, we can sum them this way. And then I can copy that down. And then my total, or the super total down here, should be 2,000 no matter which way I do it. So if you notice that that was actually given to you, let's just get started. So these we did, but I'll just repeat them. Suppose you know that the respondent is between 12 and 50 years old, so you know it's this column right here. What is the probability that he or she answered quickly? So that's how many. There were 560 respondents out of that age group. So the probability would just be that number right there divided by the total number, which in this case was 1,000. And then of course you can multiply by 100 and get 53.6%. Then it says, suppose you know that the respondent is over 70 years old. So now we're over here. What is the probability that he or she answers quickly? So now the answer is 707 divided by the total, and you get this number. Okay? So then part C says, are the two events answer quickly and age of respondents independent? And the way you figure that is you just apply this rule. So this is the rule that you find, I think it's equation 4.6 in your book, that independence requires that the probability of A given B is equal to the probability of A. So what is the probability of A given B? Well, this is where I got stuck. So I think really there's two of these. One is if they're between 12 and 50 years old, right? Isn't that what it was? Yeah, so if we do, this is between 12 and 50 years old, and this is over 70. So let's do it two times. So the probability that they answer quickly, given that they're in this age group, is, going back to the data, that they answer quickly and they're in that age group is 536 over 1,000. So that worked out to be 0.536, and the probability that they answer quickly and they're 70 worked out to be 0.707. And for the events to be independent, they must be equal to the probability of A by itself. That is the probability of just answering quickly. And that probability, looking over here, answer quickly, right? There were 1243 total people. It'd be 1243 divided by the total for that group, which is this number down here. So it's 0.622. So this over here, the probability of this is 0.622. And I hope you can see that the probabilities are different. See this? If they were young, the probability was 0.536, and that's not equal to 622, so they're not independent. And then if they were older, the probability was 0.707, and that's also not equal, so they are not independent. For them to be independent, it would have to be that when they were younger, this probability would have to be 0.622, and if they were older it would also have to be 0.622, and then they would indeed be independent because the probability of A given B would be exactly equal to the probability of A. I hope you found that helpful, and if not, ask me again in class and maybe I can explain it better. Good luck!